Ladles and jelly spoons, welcome back to Badgerworks. Today, power. This is a bit of kit I built some time ago. It's a variable voltage power supply. Now what does this mean? Basically it allows us to put power in one end and then control how much power comes out of the other end through these crocodile clips. It's very simple. Basically we plug a 12 volt power supply in this end. That tells us the system is live. We can then turn the power on, and then by using the potentiometer we can control how much voltage is coming out the other end. So you can see there's approximately 1.8 volts, but we can gradually increase that, and you can see it going up until we get all the way up to 12 volts. Now why would we want something like this? Basically it allows us to check how much power we need to make a device work. For example, if I wanted to put a light on something but I didn't want it at full brightness, or if I wanted to have a fan on something but I didn't want it to spin at full speed, I can check on here how much voltage I need to get the desired output, and then use a voltage regulator to give the device that much power when it's fitted in whatever it's being fitted into. Now there's a slight problem with this. It only measures voltage, it doesn't measure current. Also, this voltage regulator, or rather this voltage meter, doesn't like having more than 3 amps put through it. It tends to switch itself off, which isn't a lot of good for more higher powered devices. So what I'm going to do is I'm going to change this out, and I'm going to put another gauge in it, and the gauge that I'm going to put in it is this one here. Now this is a little bit of kit that I just bought recently, and this will measure up to 10 amps. So I'm going to put this in place of here. Now the problem that I have with this, it just doesn't end, trust me, is that this is not designed to work with the potentiometer. So I need to figure out a way to wire this so that I can still have the variable voltage. So that's going to take a bit of looking at. However, I do have a wiring diagram here, which is very conveniently written in I believe Chine English is the phrase. So this shows me how to wire it all in, and what we'll do is we'll put it together and see what it does. But this is a fantastic bit of kit. It has a lot of features. So we can see here it measures runtime, power in watts, data set we don't really need, temperature display, capacity, so how many amp hours, voltage and current, which is the most important thing, but also energy as well. So as well as amp hours, we've got watt hours. So this will provide a lot more information than this does currently, providing we can get it to work. So the first thing I need to do is take this voltage meter out, and because obviously this is round, this is rectangular, and I need to change the shape of the hole to fit this. So that's what we'll do first. Now if we look inside here, we can see it is, as I said, very simple. We have power coming in, goes to the switch, from the switch to the potentiometer, and then from the potentiometer we have one set of wires going to the voltmeter and the other set of wires going to the outlets. So let's have a look at how this goes together and see what we can do. Now the nice thing is these wires actually do unplug from the back of here, so I think I'm going to take these wiring blocks off, put this to one side for a moment, and I'll wire these in, and then we can test it and make sure it works before we go any further. Lovely cheap wires here. They're not copper. They're quite thick though, I mean that's quite nice. What confuses me slightly with this is the instructions call for the thick red wire to go to what is, I assume, the negative of the output. However, on here, I don't know if you can see that or not, it's clearly marked as positive. So we're going to have to be very careful with this, because I don't really want to, I mean, this wasn't expensive, but at the same time I don't really want to blow it up. But we'll have a look and see what we can figure out. So I think what we need to do is, if we connect the negative to the negative, I think for the positive side of it we're going to have to connect it onto this side. I think what we might be able to do, actually, we don't need the black wire, so we can leave that. I think what I might do, because I've already got spade connectors here, I think for the sake of expediency I'm going to put spade connectors on the end of here for now, just so I can plug it in quickly and test it and make sure it works. And then that way, if anything does go horribly wrong and it explodes, I can always just plug the voltage meter back in and I'm back to where I'm started, sort of thing. And we need to connect these to the live, and this obviously needs to go to the earth. Let me just grab a couple of spade connectors quickly. Right, so there's a couple of spade connectors. So we'll pop that in there like that. So that needs to go to the live side of this, which is this one. And then we need to connect this one to the earth. Really not sure if this is going to work or not, but we'll see. It'll either work or it won't. We'll know if it works if we let the smoke out. Because as we all know, electrical devices run on smoke, because when you let the smoke out they stop working. So let's see what happens here. So let's pop those through there. Pop the top back on loosely for a second. Plug these back in. Now we're either going to have, I might just put a screw in there quickly just to hold that down. Oh no, we're alright. So, battery. Oh dear, here we go. Ready? And contact. Oh! It's working. Look at that. Marvellous. So it's reading 12.14 volts, 17 degrees, 0 amps, 0 power. So now we don't seem to be getting any results. That doesn't seem to be doing anything at all. Yeah. So that's not ideal, but it is working. This is the interesting thing, is it is working. Because at the moment, technically, this should not be working at all, because if I turn the potentiometer off, there should be no power going to the other side of this. So I'm not quite sure what's going on there, but that's very strange. Okay, well let's see what happens. We'll just turn it off for a second. We'll plug the power leads back in. So that's live, that's earth. Move that out of the way for a moment. Let's plug in something electrical. So we've got a light here, we'll use this. I'll point this away from the camera because these are very bright. So, let's see what happens. Ready? Contact. So now we can see we're looking at 11.3 volts and 0.66 amps. Temperature's gone up to 19 degrees, 7.5 watts. Which is right, yeah, because 0.6 amps times 11 volts gives us approximately 7 watts. And we can see there the power requirement is 0.005 amp hours. It works, it's just not going to give us exactly what I was hoping for. Let's try another experiment. So I'm just going to change out the battery quickly. because I want to try a little experiment. So I'm going to put a lead acid battery on, because this has no overload protection, which means that basically I can blast as much power from this as possible. So now, what I'm going to do now is I'm going to try this smoke generator and see what results we get. So we'll just connect up the positive and the negative. And we'll see what happens. So, contact. Now this is the problem I was having before, and I think I know what's going on here. So I'm going to try an experiment. So bear with me for a second. I'm going to go and take a few things apart and try something out. Terminal blocks. Never have too many terminal blocks. So basically what I'm going to do, just quickly, is I'm going to bypass the potentiometer. I'm going to take the wires out of the potentiometer and join them together using this terminal block and see what happens there. Pop that back together. Stay. Plug these back in here. Plug the battery back in. Plug these back in. So that's negative, positive, and contact. So that's definitely working. It's only reading 0.1 amps. And I know for a fact these things draw a lot more power than 0.1 amps. So I think, whew, we're going to have a little think about this and see if we can figure out exactly what's going on. So I've just made a quick change, and I just want to talk you through quickly what I've done. As I mentioned in one of the other videos on how to measure ampage, you need to make your meter a part of the circuit, and the way this was set up, it wasn't part of the circuit. So what I've done is I've taken the bulldog clip off of the earth and I've attached it directly to the earth, or to the negative of the lamp. So now let's see what happens. It should work now. Yeah, and there we go. You see, you can see there we're now getting an amp readout, 0.63 amps. So that is why it wasn't working. So what we need to do is connect this wire to the negative output, because then what we're doing is we're making this meter a part of the circuit. Instead of just being adjacent to the circuit and monitoring it, it's now actually part of the circuit. So that's what we need to do. So time to make a quick change to the wiring. I think the simplest way to do that for now, so we just take that out of there for a second. And now in theory, if I plug this back into here, and reconnect the lamp here, I think this is going to work. Let's just get that out of the way because we don't want that touching anything. Let's see what happens. Contact. Yeah. There we go, it's working now. because I had this wire in here, the earth was coming back in, or the negative was coming back in and effectively bypassing the meter. Right, so let's try connecting that up to the out of the way. Let's bring this back in. Over here actually, so I don't burn my fingers on it. So I'll put one there and one there, like that. And now, when we turn this on, we should see what ampage we're getting out of this. And there you go. 4.3 amps at 9 volts, 40 watts. So that's working properly now. That's doing what I wanted it to do. Yeah, I think unfortunately this is not going to work with the potentiometer. So I think what I might have to do is actually build another one of these boxes. I'll put the voltmeter back in here and leave it as it is, and then I'll use this for just testing low power components, you know, lamps, fans, things like that. And then if I want to test, I'll make another box with just this in it without the potentiometer, and we'll use that to test high power applications like these smoke generators. So hopefully you found that interesting. Bit of toing and froing, a bit of error checking, figuring out how to make this thing work, and it will perhaps give you some ideas for projects of your own. Thank you very much for watching, and I'll see you on the next video. Cheers, bye.